Hello and welcome to Think Like a Citizen Scientist. And we are going to be talking about and working on our daisy patch for this. And without further ado, I'm going to flick the page and say that Think Like a Scientist is a journey. It comes with a Take Action project. So I'm going to talk a little bit about working on that in a second video. But let's get started just talking about the scientific method and understanding what is a citizen science project, what type of things that might involve, like observations and collecting data, and also just a little tidbit that April is Citizen Science Month, which also has some contention in the word citizen, so we could also think of it as Community Science Month. So without further ado, let's look at the scientific method. So the beauty of the scientific method is that it allows one to test out things to create a form of understanding and answer questions. And the other beautiful thing is that by following the scientific method, we can replicate the same results over and over and over again, proving a hypothesis to be a good theory. So, scientific method often starts with, first off, some type of question or something you would like to ask, but I can also say that the scientific method can begin at any point and we can work backwards to discover something. For example, you can find something to collect data over time and then develop a question because of the data that you're collecting, like a weird anomaly occurring. So, oftentimes when we're going to actually run through an experiment, we start with a question which we formulate into a hypothesis, which is basically the question that we're going to seek to answer. Once you've come up with the question that you're going to seek to answer, i.e. hypothesis, you're going to develop an experiment. This is a way of testing your hypothesis, and your experiment should have two types. It should consist of having the experiment itself, which will be something that is changed, and you should have a control, something that would be unchanged. So, for example, we like to do an experiment called magic milk at our house, where we take a little bowl of milk and we put food coloring in different sections on the milk, right? And then we use soap on a Q-tip in the center to break protein bonds and stir the colored dye around. What I might do as a control is I might have a bowl with the milk that I put the food coloring, and then I might have a Q-tip without soap to set in the center and see if I get the same reaction. That would be a control, where everything is the same except for the agitator, so that I can test the agitator, i.e. the soap in the experiment. From there, I would collect data on what I see, right? And I would record my observations, which the data can be what I see, it could be what I hear, it can be measurements of changes of things, change in temperature, it could be numbers of things, like so many rotations of the food coloring, for example. So we can take different observation results, and then finally we can analyze those results and draw conclusions. And these are educated conclusions based on the data. So you want to make sure that you are educating yourself on what you're seeing. So for example, what I would do is I would put my soap Q-tip into the top bowl of milk, and my non-soap Q-tip in the other one. So this is just a Q-tip. I will observe that only the one with the soap has the breaking of the protein bonds that would make the food coloring rotate. And I'll put a little video in of this happening as an example. And I would write down that the only one that had a reaction was the one with the soap. So my analysis would conclude that the soap must act as an agitator to cause the milk to break down or make the food coloring rotate, which is i.e. the milk breaking down. That's our example. So that's my scientific method. Let's talk a little bit about some other forms. So hypothesis, law, and theories. These words get thrown around a lot, and we often hear people say things like, it's only a theory. A theory is not a question. A theory is something that has been proven. So a hypothesis is the question itself. A hypothesis is untested. If a hypothesis is tested and turns out to be true and I can replicate it, which means I can do the experiment again and find it to be true, and I can do it again and find it to be true, I would say that it was supported by an experiment and therefore is a theory. On the other hand, laws are something even more firm. If I can do an experiment and it's always true, it follows the laws of physics and nature, then I would say that it is a scientific law. It is always true without question, and there is no other explanation except for this one explanation. That is a law. When we talk a little bit about engineering, which we'll do with our badges, I will talk about Newton's laws of motion, and we'll talk about things like the force of something, and those sorts of processes. Those are laws. This is always true. I could go to another planet at another place anywhere in our universe, and it will be true no matter where I am. This is a law, a scientific law. So, I love these little cards. I know that it's just a picture of the cards, but I love these little cards because they explain it so well. It says, a hypothesis is a testable explanation to a question, so I can test something. Doesn't mean that it's a fact. Just means that I can test it. A theory is supported by a large body of scientific evidence. It means that it is a hypothesis that I have tested many, many times, and it's turned out to be true every time I've tested it. And finally, a law describes what nature does under certain conditions. And this is always true. And there's oftentimes a mathematical equation that's tied to it. So let's talk a little bit about this scientific method. This is going to be a bit of a game, and I'm going to ask you to maybe pause when you do things, but I basically have this little sheet, and we're going to talk about collecting data. So one of the parts of our scientific method was the act of collecting data, and this is a big piece of being a good citizen scientist. To be a good citizen scientist, you want to help collect data so that they can help answer questions and analyze things within environments. And we have lots of different citizen science projects that we can do, but oftentimes the part that the average person participates in is data collection. So let's talk about recording information for scientific purposes. First off, we're going to create a set of observations, and we want to jot down some information that might go with our observations. For example, the time and date that we're going to look at something. So the date and time that we're looking at information. Another piece of thing that I might want to write down is the conditions. For example, if I'm looking at wildlife outside, I might want to write down whether today's weather was a sunshiny day or a kind of rainy, drizzly day. So I might want to put down things like weather conditions. Maybe the temperature. Is it summer? Is it winter? Is it spring? The season. So I might want to write down weather and season in case something only shows up in the summer months versus the winter months. So I might want to write down things like time and date, weather and season. Another big one is location. The stuff that lives up north here in Connecticut, where we live in Ridgefield, Connecticut, does not necessarily live in someplace south of here like Florida. So we're going to want to write down where we're located in our observation. And then finally, we might want to not just write down what we're observing, but also create maybe a grid or an understanding of where those things are in relationship to where we're making our observations. So for example, we might want to record some directions. Like we might want to figure out where north is and have a little north arrow on a map grid and tally in our observations the location of things that we found. So popping back to that little grid that I made on the previous page, we can see we have some observations. Let's say we have a little swatch of ground outside and we're going to observe some rocks and minerals outside. And my rocks and minerals consist of red squares and purple circles. Some of the information that I might want to jot down is the location of things that are red squares, so the number and location of red squares, and the number and location of my purple circles. So I would count it up and I would say I have 1, 2, 3, 4 red squares and 1, 2, 3, 4 purple circles. And I might even want to jot down while I'm making the observation some of their locations, since rocks and minerals are stationary. So I would maybe write down something like 4 purple circles, and then write down the location of my purple circles. So there was one about here, one kind of in the middle over here. I feel like there was one to the side over there and one down here, right? And then I'm going to change my color just to keep track. I'm going to write down 4 red squares. And I'm going to write down their locations. And I'm going to say there was a red square kind of up here, and one down here, and one kind of over here, and one over here. So now I'm going to just go back and just check. Not too bad. We did pretty good on that. Okay, so now, for an example as to why I would do this, all of a sudden there is a giant flood that washes through. And something changed, and they send me back out into the field to make observations to see what types of rocks and minerals got carried away in the giant flood. And because I have this sheet, I can record accurately the change in my environment. So now I'm going to flip back to my previous page and see what changed on my new date and time. Let's see. Oh, so some stuff did get carried away. Now all of a sudden I have 1, 2, 3 red squares and 1, 2 purple circles. So I would make a new observation sheet. I would put down the date and time that this occurred. I might write down the weather, or I might make a note that this is after a flooding event, because I said that that's what occurred, and I might write down all this information. But because of that, I can now compare my previous notes with my current ones, and I can say, you know what, we lost some circles. I lost this circle here, and I lost this circle here, right? In my previous page. So I lost my circles, and I can say that we lost a square too. So I lost some square too. So now I'm down to 3 squares, and I would write my notes over again, and I'd write new things, but I can create a comparison. And I might even be able to draw some conclusions. And so this is how we make observations. This is how we put down information. And it's okay to put down more information rather than less information. So on that note, we've kind of completed talking about the scientific method and making observations. I'm going to make another video about ways that we can participate in citizen science and do these special observations and take part in working on this badge. So I hope everybody is doing well and is happy, healthy, and safe. Bye, my Girl Scouts!